Okay, I'm going to offer you some help on the second problem in your homework, which is calculating the ideal mechanical advantage for the screw, as well as the ideal effort force needed to overcome the resistance of 425 pounds. So this is like a basic, like a wood screw that you'd see just like this. There's two images. The first image shows you I don't know if it's the first or second, but one shows you the diameter across the threads, which shows a quarter of an inch. And then the other image, which I can't show you on this printout, but you can see if you slide to the next image, will show the threads across 1 inch, where you can count how many threads there are per inch. Okay, so that information that I retrieved by looking at the image, the diameter of the screw is 0.25 inches, and the threads per inch, or TPI, I counted 9 threads per inch. Okay, so just to give you an idea of what we're looking at here, we've got a little screwdriver handle. The other thing it said in the description is that the screwdriver handle has a 1 inch diameter. So that would be like this handle right here, which I think is pretty accurate to the one I'm holding without measuring it. So handle diameter equals 1 inch. Okay? So just to kind of sketch this out, top view, this would be my screwdriver handle. Is 1 inch, okay? And that's a diameter. This is a symbol for diameter, okay? So that would be like a top view, looking straight down on it. And then if I were to see through it, you can kind of see the head of the screw. You can kind of see that right like that underneath it. This is a wheel and axle. If you look at it, I've got a large wheel, and I've got my axle, which is the screw. That screw diameter, you can see right here, is 0.25. We measured that from the image, so diameter is 0.25. So according to my calculations now, again, the screw has two simple machines working together. So if we look at this, this is one simple machine, the wheel and the axle. Okay, so we're going to use IMA to calculate the first, so distance effort over distance resistance. So on a screw, I'm applying my effort to the handle. I'm twisting the actual screwdriver. So that's the wheel. So my effort is 1 inch. Now, since I have diameter of the wheel and diameter of the axle, I can compare those two distances. If I had radius up here, I better use radius down here. If I had circumference up here, I better use circumference down here. So as long as I'm using the same measurement type, I can do 1 divided by 0.25, all right, which equals 4. So my IMA for this first simple machine, which is the wheel and axle, is 4. Okay? But I have a second simple machine. Let's do the second one down here. If I look at this from a side view of what's happening, kind of like that, I have, my screw, my threads, all right? And then I have my screwdriver. Say this is the handle. There's the top of it, and then I have my drive that kind of fits right into the top right there. Every time I rotate my handle, you're going to remember my distance of effort, my DE, is the full circumference. Remember, I'm rotating this one full turn. One full turn. So my distance of effort is the circumference, 2 pi r, of that whole circle. So the radius would be 0.5. 2 pi 0.5, right? So that's my distance of effort, is that full, complete circle that I'm traveling to rotate it one time. My distance of resistance on the bottom is going to be how much this screw lifts, all right, up or down, depending on which direction I'm turning it, for one thread. Now, according to the threads per inch, there's 9 threads per inch, so I could quickly do the math and just say 1 over 9, or yeah, 1 over 9, 1/9. So according to my calculator, that's 1 or 0.111 repeating. So if I just kind of punch that out, do some math, my IMA over here, 2 pi times 0.5 divided by 0.11 gave me an IMA rounded to 28.29. You can see how much lower that is when you don't have a wrench that comes out. That's why screwing things in with a screwdriver can be very tiresome on your wrist, because you don't have that leverage like a wrench would give you leverage coming out. So that's why it gets tiresome. So that's your IMA for this portion of it. But remember, this is a compound machine, so I have to do this IMA times this IMA. So 4 times 28.29 gives me the IMA total. IMA total, which, if I multiply those together, IMA total equals 113.15. There you go. So that gives us the solution to the first question, which in this case was, what is the ideal mechanical advantage of the screw turned by the screwdriver with a 1-inch diameter handle? Second question says, this should be very simple, what's the ideal effort force needed to overcome the resistance of 425 pounds? So the force, effort, ideal, let's say, was 400, I'm sorry, we're solving for the force effort of ideal. So what is that if the force of resistance is 425 pounds? So that's the question. Well, if I look at AMA, let me freshen up my paper here so I don't have so much junk in your way. If I look at AMA, all right, that's force resistance over force effort, right? Now I know I'm not looking at actual mechanical advantage here, but I can use the same formula to solve for that. And if I look at these two numbers, and I look at my ideal mechanical advantage that I've solved for, I can kind of put this in here and say 113.15 equals, and my force of resistance, that's given to me. It's saying how much do I want to, what's my effort if I want to overcome 425, right there. What would be my force of effort if 113 was ideal? So then I would go ahead and I would use my algebra and I would solve for my force of effort, which is my unknown. So essentially, this gives you your solution right here. Okay? So that would give you the solution. I'll go ahead and I'll put this video right next to the problem to assist you. Thanks for watching. Give me 5 stars. Have a great day.